Plotting interactions can be quite interesting. So in order to do this, first I'm going to show you a complicated plot and perhaps what not to do. And this is a plot that's available. I'm going to bring this in. And this is a surface plot. And you can see here we've got our primary predictor x1 and our moderator, and then our y, our criterion variable, and we got all sorts of colors, and it's difficult to interpret simply because, well, one, I'm probably 3D challenged, and most people are. It's difficult to interpret this, and we're accustomed to having plots that are two-dimensional, and then we just add layers onto the 2 dimensions for easy interpretation. So that 2-dimensional plot would look something like this. Oh, guess I should do this. And I'll have to change that later. Hangover from previous model that I ran, and this is normally the way we look at it. So we look at this is when x2 is equal to 0. The red dots are where x2 is equal to 0, and the red line is the line of best fit. And the x2, when it equals 1, is blue, so it's all the blue dots in the blue line. So what does this mean? Well, remember in simple slopes and simple intercepts that we found that if there's a significant main effect for the moderator, that there will be a difference in the intercepts. And if there's a significant interaction, that there'll be a differences in the slopes. And the reason why we know that is that the moderator parameter goes into the simple slope, and the interaction parameter goes into the simple slope, and the moderator main effect goes into the simple intercept. And what we're seeing here is everything significant, so we have differences in intercept and also differences in slope. The other way I could do this is my previous contour plot. I could rotate it, and if I rotated it, I would see approximately the same plot, where this is when we have our moderator is 0, and then if you go into the depth of the plot, this line represents where the moderator is equal to 1. And this is a response surface, so the wireframe actually does characterize the interaction better than the 2-dimensional plot. It might characterize it more accurately, but that doesn't mean that it's more interpretable. And so most of us, we rely on the 2-dimensional plots. So remember when I calculated the simple slope and simple intercept, well, what I can do is I can do a side-by-side plot of this, and you can see that on the left-hand side, this is the plot that I calculated using my linear model, and this is the plot that I calculated this plot using the simple slope and simple intercept, and you see that they're identical. So simple slopes and simple intercepts, while it might require a few steps in order to calculate them, it is an easy way to interpret the effects so that you're not struggling to try to figure out how to interpret significant main effects for your moderator or simple interaction effects, and so that you can easily characterize them and communicate them in the papers that you write. So that's the reason why we try to plot them. Sometimes we plot them for ourselves, and other times we plot them for our audience. So I put in here, whoa, they're the same even if I rounded the values, and sure enough they are. So that's plotting, and every graphical package and statistical package is going to have a different way of handling these things. I'm including my R code for those R users, mostly because interaction plots are a little bit more cumbersome in R. There are functions to do it, but I find them to be difficult to follow. SPSS, you can easily do this just by subsetting your data based upon your moderator. And remember, as I talked about in terms of the simple slope and simple intercept, is you can create as many splits in your moderator as possible to facilitate the interpretation. So that's enough you're going to play around with plotting functions during this week, and we'll talk about that shortly for the in-class assignment. So stay tuned for the next few videos.